Okay, let's start with this log problem. I just put it all up here and then I'll talk through it and you can pause it and look at it if you want to stare at it longer. So here's the original problem, y equals log base 4x. So to start the problem, you need to change it to exponential form. So that would be 4 to the y equals x. That's how you change log form to exponential form. So that's how we get 4 to the y equals x. Now we make a table of points, x, y, and usually we would pick a value for x and then find y. We'd put values in here for x. But the problem is that if we put a number in here for x, it's going to be very difficult to figure out what y it is. So it's going to be easier to put a number in for y and then figure out what x is. So I pick my numbers for y to be 2, 1, 0, -1, and -2. You always want to choose the positives and negatives when you're doing exponential or log functions and graphing. Okay, so if I take my 2 and I put it where the y is, I get 4 to the second equals x, which is 16. If I take my 1 and put it where the y is, I get 4 to the first equals x, which is 4. Then 4 to the 0, anything to the 0 power is 1. You got to remember that rule. Anything to the 0 power is 1. 4 to the -1, remember a negative exponent means reciprocal, so that would be 1/4. And 4 to the -2 is 1 over 4 squared, which is 1/16. So now I just graph these points, x, y, x, y. These are like ordered pairs here, like this, ordered pairs. So over 16 up 2, that doesn't really fit on my graph very well. I'll do this in blue over what I've got so you can see how I'm doing it. And 4, x is 4, y is 1. That would be here. X is 1, y is 0 would be here. X is 1/4, y is -1. X is 1/16, very close to the y-axis. Y is -2. And then if we kept going, it would just get closer and closer to the y-axis but never touch it. And that's how we get this graph right here. And then just make sure you put arrows on both ends because it's going to go both directions. Remember, we got this point 16, 2 way out here. It's all headed this way and it's going to keep going. So that's why you need to put arrows. So you can pause this if you need to look at this a little bit more, and I'll get ready for the next problem. So the next problem we had was 3 to the 9 minus 3x equals 27. So with this problem, what you want to do is get your bases the same if you can. See if you can get these bases the same. And since 27 is 3 to the third power, we have the same base. We have a base of 3 on both sides. So then what we can do, once we have the two bases equal to each other, if these two sides are going to be equal and the bases are equal, then the exponents are going to have to be equal, which is this rule over here. M to the x, if m to the x equals m to the y, I should say if we have m to the x equals m to the y, then x would have to equal y. And so this is our m value here, 3. And so we have a situation where x, which represents this exponent, and y, which represents the other exponent, those would have to be equal to each other. Essentially, you're just kind of dropping the bases out, but this is y. So now we need to solve for x. So I'm going to minus 9 from both sides and get -6, divide both sides by -3, and get x equals 2. You can check your answer by plugging it back up in here for x, which I did here in blue. So 3 to the 9 minus 3 times 2 would be 3 to the 9 minus 6, which is 3. 3 to the third is 27, which is correct. So we have the right answer. So go ahead and pause this if you need to look at it and write it down. And the next one I need to write down. I don't have it written down, I don't think. Let's see, I gotta go look at it. I think it was 8 to the x equals 16 to the 3x minus 1. This problem is like the other problem because we can get the same base. 8 is 2 times 2 times 2. So 2 to the third to the x. 16 is 2 times 2 times 2 times 2. 2 to the fourth. 3x minus 1. And you just got to kind of look for that. When you've got variables in your exponents, you're looking to use this rule where you can just set the exponents equal to each other. But you can only do that if the bases are the same, and right now they're not the same. 16, you could have written that as 4 squared. That's also 16, but I can't write 8 as 4 to any power. So that wouldn't have helped. I'm going to have to go and make 2 my base. Using the rules of exponents, I need to multiply these two exponents together and multiply this, power to a power. So I get 2 to the 3x equals 2 to the 12x minus 4. You have to distribute that 4 to both of those terms. Now I've got a situation where the bases are equal, so I can just set the exponents equal to each other. So 3x equals 12x minus 4. Now I solve for x. So I'm going to subtract 12x from both sides, which will give me negative 9x equals negative 4. Divide by negative 9. This pen doesn't like horizontal lines. And then I get x equals 4/9, which is the correct answer. Alright, I hope that helps.